everybody, it's Mrs. Pound, and I'm back with another chapter from Purposeful Designs, Earth and Space Science. We're up to chapter 1.4 about the structure of the Earth. And the first part of the Earth we're going to talk about is the core in section 1.4.1. So our objectives for this video are to explain how seismic waves are used to determine the features of the core, describe the two parts of the Earth's core, explain how the core generates a magnetic field, and describe the benefits of the magnetic field around the Earth. So when we're talking about the core, we're talking about the central portion of the Earth, a lot like the core of an apple. It is comprised mostly of iron. There are two parts of the core, the inner and the outer core, and they both contain mostly iron. Now, we cannot directly observe the core of the Earth because it is simply too deep. The deepest we have been able to drill into the Earth is 12 kilometers, which is not even close to the core. So we have to if we can't make observations directly, we have to make them indirectly. And one of the things that we use to make observations about the center of the Earth indirectly are seismic waves. And actually, this idea of the center of the Earth, it has fascinated people for a very long time. In fact, Jules Verne in 1864 wrote a book called Journey to the Center of the Earth, where he wrote an imaginative story about what he thought the center of the Earth was like. And so if you're interested in that, you could read that book. There's also been movies made about that book, so you could watch one of those as well. So a seismic wave is a wave of energy that travels through the Earth. They are produced by earthquakes, so we actually use earthquakes to study the interior of the Earth. Now, there are two types of seismic waves. There are P waves and S waves. P wave, the P stands for primary. This is the fastest seismic wave, which travels through solids, liquids, and gases. There are also S waves. These are seismic waves that travel only through solids. So only through solids. And to keep them straight and to remember that, so primary faster because it gets to someplace first, secondary slower, and also S waves, the S stands for solid, we could think, for it only goes through solids. So that could help us, where primary waves travel through all three states of matter. Now, we know about the inner core. We know that the inner core is the solid center of the Earth. It's the hottest part of the Earth, and it's solid due to extreme pressure. We know this because the primary waves actually speed up when they go through the inner core. They're able to go through all the layers of the Earth, and they speed up when they go through a solid. So that's how we know that this is solid. And even though it's the hottest and we would think that it would melt everything, because it's such high pressure, and it's almost as hot as the surface of the sun, okay? It's almost as hot as the sun, but it's because of extreme pressure that it is actually a solid. And there is also the outer core. This is actually liquid. We know it's liquid because the S waves will not go through it. Okay? The S waves, remember, can only go through a solid, and they will not travel through the outer core. So we know that it is liquid. And the cool thing about this liquid is that it moves. And as it moves, it generates electricity, which in turn, it causes electric currents, which in turn generate a magnetic field. And so this is what makes the Earth like a giant magnet. And so that's why we can use a compass to help us find direction. Another thing about the magnetic field that is beneficial to us is that it protects us from the solar winds produced by the sun, so that we're protected from radiation. due to our magnetic field. And I think that this just shows God's handiwork in creating the earth. And if we take a look at Psalm 95.4, the psalmist says that the depths of the earth are in the Creator's hand. So every last little detail about the earth, God thought about. And he knew that we would need protection from the sun. He also created something beautiful with, we call this part of the earth affected by the earth's magnetic field, the magnetosphere. He created something beautiful from it as well. The aurora borealis are a result that you will see like around the Arctic, a result of Earth's magnetic field. So he also, just has the eye of an artist in many aspects because the auroras are just so beautiful. So I want to go to the reference tables now, so I'm going to switch to my other camera. Okay, so this diagram is about the inferred properties of Earth's interior. And it's inferred because we don't have direct evidence. We're using those seismic waves. So all of this data that you're seeing is inferred. And what I want to point out is that to the center of the Earth is over 6,000 kilometers. It's over 6,000 kilometers deep to the Earth's center. And here also you will find, let's zoom in here, if you want to know the composition of the core, iron and nickel. Okay, iron and nickel, it's right there on your reference tables. Now, this makes the core actually look smooth here, but actually the core is a lot like the surface of the Earth in that there are peaks that go up into the mantle and there are valleys where the mantle goes down into the core. So you will see variation in that, just like you see on the surface of the Earth. You'll also see here densities. We can see as we go towards the center of the Earth, it becomes more dense, which makes sense that those things that are most dense would sink towards the center of the Earth, okay? Another thing we see here, and as we follow these lines down, these lines show the data for the different layers of the Earth. We're focusing on the core right now. We can see that pressure increase. Okay, we see that pressure increase as we go towards the center. We also see the temperature increase as we go towards the center. And we also see here there are some melting point lines. And so this can tell us whether we have a solid or a liquid in these different parts of the Earth. Okay, so if the melting point is below the interior temperature, then it is a liquid. And so we can see here the melting point line is below the interior temperature for the outer core here. And so that's why it's a liquid. Up here, this is the inner core region. We see that the melting point is above that interior temperature line. And so it's a solid. And so we can see using this whether each layer is a solid or a liquid. So these are some useful things that you can look at. Now, we're just focusing on the core this time. We will take a look at the other parts of this in the other videos when we talk about the mantle and the crust. Okay, so our objectives for this video were to explain how seismic waves are used to determine the features of the core, describe the two parts of the Earth's core, Explain how the core generates a magnetic field and to describe the benefits of the magnetic field around the Earth. And so don't forget your 5 questions, and I will be back with more about the structure of the Earth in other videos.